All right, so this is our practice quiz. We have two problems, and they're going to be find the inverse. That's our problem. So the first one might be kind of easy. F of x equals 4x plus 1 over 9. Now, the steps are the same. No matter how big or ugly the problem is, the steps are the same to begin with. So what's the first thing we're going to do?
Which put it to y
We're
equals.
going to make y equals,
You switch the y in.
and then switch the y and the x. So we have x equals 4y plus 1 over 9. Now, as Katie said, some of you can go straight from here to here. I don't care, but you got to have this, right? And then, plain and simply, we have to get y by itself. Now, that's not going to be hard here, right? We're going to multiply by 9. Subtract 1. Divide by 4. And then in the answer blank, it'll say what's F inverse. That was the question. It's right here. It's when you get y by itself, it's whatever y equals, that's what you put in the answer blank.
So why don't we like solve it? Like, no, never mind.
What do you mean solve it?
No.
Okay.
So at the top, you wouldn't like. Bless you.
You wouldn't what?
Like simplify the top.
How would the top simplify?
Would it be like 3x but minus 1 here is plus 1?
There's no squared there?
Oh, okay. If there was a square, would we do it?
No.
Okay.
I mean, you could, and it wouldn't be wrong, but there, you wouldn't. There's no reason to do that.
If we rewrote. Never mind. Why am I asking for
Yeah. Let's not make it harder than it is. Done. Right? As soon as you get y by itself, you're done. Now, that's problem 1, okay? Pretty easy, pretty straightforward. Problem 2 will look more like the ones we just did. Directions are the same. This time it's 3x plus 8 over 7x minus 2. Now, we're certainly not going to panic because don't we start the same way as always? Okay, so we'll start by changing that into a y. And then switching our variables. Please don't forget to do that. We do that in every single inverse problem. Okay? Everybody at this point okay? Jameson? Okay. So now what? We're going to multiply this over to here, right? So we're going to have x, 7y minus 2 equals 3y plus 8.
This is more we factor, right? Than these ones. Not factor, but
Pull y.
pull y.
Well, I'm going to pull y out, but not yet. I can't pull y out yet. Now I have to distribute, right? Look, you got a y over here and a y over here. You can't deal with that. I mean, we got to fix that problem. So 7xy minus 2x equals 3y plus 8. Right? Now what? You're thinking along the right lines. You know you need to get those y's together. But first we're going to have to do the switching, right? We got to switch. So this is going to come over here, and this is going to come over here. So we're going to have 7xy minus 3y equals 2x plus 8. Now now we can take the y's out, and that will leave us with 7x minus 3. And then what do? Divide by the parentheses, so we have 2x plus 8 over 7x minus 3. Is that right?
Yeah.
And so my answer in the answer blank, it says find F inverse. So F inverse is just whatever y equals. So that's 2x plus 8 over 7x minus 3. Okay? So that's the quiz question, or the quiz tomorrow, or whenever it is, next class. We'll have 2 problems on it, and we just practice the kinds of problems on it. Okay? All right? At the end of the period, we'll do another one of these if we have time.
This is 4.
Yes?
Like, if we take the test, so you get off class mark, you take it on, or the quiz on Friday, would it go in this grade?
Yes.
Okay.
All right. Okay. Now, back to our notes. Now, we're going to talk about more stuff, but what's on the quiz Friday? What we just did, right? So we're talking about more stuff, but this is not on the quiz Friday. Carol. I don't know. It might be 8 or 10 probably. Okay, here we go. Number 2. Okay, we got a picture. We know what that is. That's a squaring function. And it says there's 3 questions to answer. Is it a function?
Yes.
Yes, it is a function. How do we know? Yes, it passes the vertical line test.
Write all that out.
No, I am writing it out because you need to be able to explain if you have to. How do we know something is a function? It passes the vertical line test. Remember, the rule is if you draw down vertical lines, they only hit your picture in one place. Each line, one place. So when I draw this vertical line, it hits right here, one time. All right, that's how I know if it's a function. Now the next question says, is its inverse a function? Is its inverse a function? And the answer is no, because it fails the horizontal line test. There is. And here's why this happens this way, you guys. I want you to think about this for a second. If I draw a horizontal line across here, do you see how it hits here and it hits here? I don't know what those points are, but let's say this one is negative 2,6, and this one is positive 2,6. I'm making those up, totally made up. But they would have the same y, right, since they're the same distance up. Remember when you do an inverse, you switch the x and the y? Remember that step? If we took these 2 ordered pairs and switched the x's and y's, then the x's would repeat. And if the x's repeat, you are not a function. So you can look at one picture and tell if it's a function, yes, vertical line test, and if its inverse is a function. You don't even need to draw the inverse. I don't know what the inverse looks like, but I know it's not a function. Because if it is, it would have to pass the horizontal line test. And it doesn't. Is it 1-to-1? No. Because to be 1-to-1, you must pass both tests. 1-to-1 means no x's repeat and no y's repeat. You pass both tests. This picture does not pass both. All right, let's look at the next thing. Same questions, but this guy is like a sideways V. First question, is it a function? No. It fails the vertical line test, right? Not a function. Is its inverse a function?
Yes.
Yes. It passes the horizontal line test. Is it 1-to-1?
No.
No, because it must pass both tests. All right, we got one more of those. We have a line. Is it a function?
Yes.
Yep. Passes the vertical line test. When somebody says to you, is this a function? Vertical line test. Is its inverse a function? That is the horizontal line test, and it passes that one too. Right? Is it 1-to-1? Yes, because it passes both tests. Can you think of, don't say it out loud. Don't say it out loud. Write it on your paper. Can you think of another BFF, not the line, not the identity? Can you think of another BFF that is 1-to-1? There are others, so don't think there's just one answer. There's lots of answers. Think of one and write it down. Think of a BFF that is 1-to-1. Boys, I need you to hold up your paper with your answer on it. Think of a BFF that's 1-to-1. Hold up your paper with your answer on it, please, in front of your camera so I can see it. Zane, hold it up for me, I can't see it. Just the name or the picture or something, one of the functions, it's 1-to-1, just one. That, okay, I said anything but a line, not the linear. We did that one already. Find another one. David, Antoine, hold one up so I can see it. Draw it for me nice and big.
I do too.
We're doing a linear one. I did too.
You can do whatever you want. I want you to hold it up and not talk about it. I see what you did. Zane, thank you. Okay, I see that, Antoine. Thank you.
Who says that?
Harry, one more.
David, one more second, and I'm going out to get the rest of the class. What are you holding up there for me? Okay, thank you. All right, let me come around and see what you guys came up with. Where's yours? Yep. Yep.
Both of them work?
Why are we looking at the first one? Yeah, they both work. Okay, now, good work, folks. We need to talk about a couple that were out there that don't work. All right, we gotta talk about a couple. Because your job was to come up with one of your BFFs that is one-to-one. Now, is one-to-one means it passes both tests. Okay? It passes both tests. A couple of answers that I saw were a little questionable. One is this. That's the absolute value function. Definitely a function, but not one-to-one because it does not pass the horizontal line test. Another one is this one. That's quadratic or squaring, definitely a function, but it does not pass the horizontal line test. Therefore, it is not one-to-one. Now, some that I saw that do work, a lot of you had cubing. Absolutely, passes both tests, right? Many of you had, I'm not sure why, the square root. I mean, it's a great function, and it is one-to-one. And somebody, I think it was Jameson, had the logistic function, which is definitely one-to-one, kind of one that's kind of off the beaten path, but definitely one-to-one. Okay? So, good work. Those of you that said these, do you understand why that's not one-to-one? Guys, everybody understand why that's not one-to-one? Okay, we gotta pass both tests. Both tests. Okay, next. Sketch the inverse. Now, here is what I would like for you to do first. Before you even start this problem, would you go through and label all of the points? So for example, label this point 0, 1 and 1, 0.
It's on the next page.
Yes. Yeah, the next page of our notes, we're just going through. So then 2, 2. I want you to label these points if you would, please.
On our empty graph?
Yeah, right. No, right on the graph itself. Not on the answer graph. We have to draw a new picture down there. But right here, just like I'm doing, right next to the points, label it. You don't have to draw the picture like I do, but label the points.
Would that be 2?
You know what takes us so
And
like what is it?
I think it's -2, -1, and -3, -1, and -4. Okay, so I have labeled all of my points. Right there on the graph itself that I drew, I labeled all those points. Now, on this graph, I'm going to draw the inverse. This is very easy. Remember, when you're dealing with inverses, X and Y switch. X and Y switch. So I'm going to start over here with the very first point. And originally, it's -4, 0. So on my inverse, I'm going to plot 0, -4. X and Y switch. Whenever you're dealing with inverses, everything switches, X and Y. So this is the point, -4, 0. So for the inverse, I'm going to plot 0, -4. This is the point, -3, -1. So I will plot -1, -3. -1, -3, switch them. And then I'll plot -1, -2. And 0, -1. So far, if I connect what I plotted, I have that little shape right there. Alright, I got to here. Okay, now what happens at this point? That becomes the point 1, 0. And then 0, 1. And 2, 2 stays the same, right? When you switch it. And 0, 3. Now, if you look at what you ended up with, compared to what you started with, do you see similarity? The difference is, this one was kind of sitting on the x-axis, and this one is sitting on the y-axis, which makes sense when you think what you did was switch the variables, right? What? Huh? We are doing great, JD. We're doing great.
I need a
Yep. So go ahead and get the original picture. Identify your points. Here's the original. Now see if you can draw the inverse. You only have 3 points this time, so it shouldn't take very long. Remember, when you draw the inverse, you just take the points that you're given and flip-flop them.
So the top would be 2, 0.
That point becomes 2, 0, right, which is over here now. This is 2, 0. That's that point right there, yep. And that one becomes 0, 2. And that one becomes 0,
You
-2.
have like a little, like the pointer point next to it, or if you just put the dot there. You just put the dot, or do you have to write 2, 0 next to the dot?
You don't have to write that next to the dot, you don't have to. So what happened was, we had a semicircle on the top, and now we have a semicircle on the right.
The next step is probably on the SAT.
Is it?
Yeah.
Yeah, it is 100 meters.
Alright, so does everybody know how to graph an inverse? To graph an inverse, you take the ordered pairs of the original and simply switch them. And then put the new points on, connect them, and that's your answer. Alright, the next section, which apparently was an SAT question, deals with what are called parametric equations. Alright, parametric equations. So just write that little word next to number 4. Just write parametric equations, because that's what this is called. So this particular section, 1.5, has 2 ideas in it, inverses and parametrics. So we've talked about inverses, gonna have a quiz over them on Friday, and now we're talking a little bit about parametrics. Alright, so here's the deal. This says, find an ordered pair, x comma y. Find an ordered pair if we let t be 1. Because it's so easy.
Oh, you put in,
If t is 1, then your x coordinate will be 3, and your y coordinate will be negative 3. All you do is take the t value and plug it into your equations, and that will give you an x and a y. That was your job, find an x and a y. Now the next one is exactly the same, except the equations are different. Don't be freaked out because there's a radical. You do exactly the same thing. So this time we're doing it for t is 7. So you're finding an x and a y. So if we put a 7 in, x works out to be the square root of 4, which is 2. And if we put a 7 in, y turns out to be 49. There's your ordered pair.
Wait, how'd you get 2 from x?
What's 7 minus 3? One step at a time. Okay. All right. Now the next section, the directions are more confusing, but it's kind of the same thing. It says find a direct algebraic relationship between x and y. So what that means is,
you gotta find what t is.
exactly, and then substitute it back in, or eliminate it. So here's the deal. You gotta get rid of the t's. This says find a direct relationship between x and y. So we are gonna get rid of the t's. Gabe, what are you doing back there? Okay. We gotta get rid of the t's. Now, you have 2 choices to get rid of the t's. In the past, many students have liked to eliminate them using regular elimination. So here's what I mean. If I took these 2 equations and I multiplied the top one by 2 and I multiplied the bottom one by 3, look what's going to happen. You can probably see it already. I would have 2x equals 6t plus 2. I'm multiplying that equation by 2. And then I would have 3y equals negative 6t. If I add those together, straight down, just add them together, I would have 2x plus 3y on this side equals, that's gone, and I would just have 2. Now, the directions said, find a relationship between x and y, period. There it is. There's the answer to the question. All you have to do is get rid of the t's. Now how you do that's up to you. This is elimination. I'm going to show you another option here in a second. But this is easy for a lot of people, just straight elimination. Does everybody understand why I chose to multiply this by 2 and this by 3? My objective is to get rid of the t's. I had to make the t's cancel out. I don't care about the x's and the y's. It's the t's that have to go. Okay?
I have a question about elimination. So word always has to be negative?
Yeah. Elimination. The only way to add them and get rid of something is if it was negative. Yeah. Okay. Now, let me show you the other option. And as always, you don't have to do it both ways. I just want to give you another way to do it if you wish. So here's the problem again. If that makes sense to you and you're comfortable with it, then you don't even need to pay attention to this. But this is another option. So I'm gonna take this second equation and I'm going to divide by -2 so that t is by itself. Then I'm going to take that and plug it into here. So x equals 3 times y over -2 plus 1. See what I did?
That's hard.
I solved this for t, got t by itself, and then plug that in here, so now I don't have any t's, but I do have to clean that up a little bit. So, maybe I'll multiply by -2. Put my x's and y's on the same side. Now, is that the same equation that I came up with when I did the other way? Yeah, if you just divide out the negative. The thing I don't like about substitution is, sometimes it works great, but it often involves fractions. And when we put fractions in, then we start making arithmetic mistakes. But it's up to you. You can do it either way. But you gotta get rid of the t. So whatever you're doing, you gotta get rid of the t.
So there's t for 2?
No, there's no t value. T is gone.
So that's the answer?
This is the answer. That's the answer. Okay? So it's different than problem 4. In problem 4, they gave you a number, we plugged it in and got a number. Here, we don't have any numbers, we're just getting rid of the t's. Alright, let's try, we got a couple more. Let's try a couple more here.
Wait, would I get the same answer if I did it the other way? For that problem?
What do you mean if you
Oh,
did
wait,
it?
never
the
mind.
other way?
I did the next one.
Oh, okay.
Wait, for elimination, you just have to get one of them. Like, if you just want to multiply one of them, the x instead of the y, you can do that one.
Yeah, yeah, yeah. You don't, when you eliminate, you don't have to multiply both. I did here because I had a 3 and a 2. On the next problem, no. On the next problem, if you're going to use elimination, if you're going to eliminate on this problem, you will have to multiply the top equation by -7 if you're going to use elimination. -7x, -7t, -28. And then y equals 7t minus 3. Gone. -7x plus y equals -31. So is that what you got, Caroline?
Yeah.
Is that what you got, Mary Kate?
Why would it be a net positive y?
Huh?
Why would it be a positive? Oh wait, I just, what did you do? Multiply by 7?
I multiplied the top by -7.
I just did, so I did positive 7 on the top and then I multiplied by -1.
Perfect.
But I got 7 minus
Crap.
net minus y, yeah. Okay.
They're exactly the same, because if you divide it out in -1, this is what you would get. They're exactly the same thing. So did anybody have a question about that? Either, you got either of those, it doesn't matter which one. Anybody have a question about that? All right, would you try the last one on your own then? C? See how far you can get with problems. Remember, your job is to get rid of the t's. And what will your answer end up looking like? An equation. I don't know what equation, but your answer is actually an equation. You won't get a number like 6 or something. Okay, if your name is up here on the board, you have until Friday to get your debt paid, and then it becomes a detention. That's for borrowing a calculator, borrowing a pencil, borrowing something. That's a $5 bill. How much do you owe?
56.
Well, I better see if I have change, because I'm not sure I have. I can bring change next time, but I got credit. All right. So, what did we come up with? You multiplied what? Guys, what did you do?
Multiplied by a -3 and a +2.
Okay, now, could you have multiplied by a +3 and a -2? Yes, and your answers are gonna come out opposite like these did over here. It doesn't matter, it's fine either way. So -3x equals -6t minus 12. Make sure that you're multiplying all the way across by -3, or whatever you're multiplying by. And then 2y equals 6t minus 2. So we're adding -3x plus 2y equals -14. Or you might have gotten 3x minus 2y equals +14. Both of those are right, makes no difference. That's the end. Okay? All right, we're not packing up. Get your paper back out. We're gonna do one more practice quiz question. Or one more practice quiz for tomorrow.
Can you just write it out and do it ourselves?
Yes, and then we'll check it.
Miss
So, we have a piece of paper. We have a piece of paper, okay?
Need to change the brush.
And we're gonna write down these 2 problems, and we're gonna do them. The directions say, find the inverse.
When is the grades for this quarter, like, you have to put them in?
Next week.
All right, so let's say we have 3x minus 10, there's one problem, and 4x minus 1, 6x plus 3. All right, here they are. We only have 4 minutes. I don't want to hear a bunch of talking.
There you go, Miss
I want
Will.
everybody focused on doing these.
Before getting paid.
Okay? Do both of them, please.
So, isn't the first one from the y, like the, do you automatically put it as equals, or the unbreak?
Yeah. You do, yeah, you do exactly the same steps to start both of these. finish number 1, and I wrote my answer up here. Look up here and see if that's what you got when you're done with it. For number 1. I switched my variables.
No, not, I don't know what the
Okay, well, I haven't done number 2 yet.
I think I'm trying to find.
Did you switch your variables, Kenny?
Yeah,
Okay, then you add 10.
I got negative 10x.
You add 10 to both sides. This is a minus 10,
Yeah.
so we have to add it to both sides, like regular equation solving. That's what you need to do. You need to add 10 and then divide by 3, which you did do that. You divided by 3.
Oh, I see.
All right, let me get this one going. Let's see what we came up with here. Running out of room. My second one, I'll put the answer up here. You can check to see if that's what you got. Here's what I got for the second one, but then we can go back and talk about any steps that we had confusion about. Katie?
Here, the first one, I put it, the inverse is negative x minus 10. Can I just do it like that, or do you want me to put it like x plus 10?
Okay, wait, negative x minus 10 over negative 3?
Over positive 3.
No, that would be wrong. I don't know how you got those negatives.
Oh, wait, no, it's a positive. Yeah. How did you get negative 3? I don't know, I had positive 3. I got 6x squared more over 3x. I got it like that. I don't know.
I mean, that will work for you. That will work. I want to discourage you. But be careful. There really isn't a reason to have all those negatives in there. But if that's the way you want to do it, it's okay. Just keep track of all of them, please.
This, wouldn't this be negative 1? What? Is that one right there?
Yeah, Caroline found a mistake here. Somehow I ended up with a 3 instead of a 1.
Yes,
So does that look better? This was a 1.
Okay, wait, Miss Ford. I got 6 minus 4. Or I got 6x minus 4 over 3x minus 1. I flipped them.
If you study
Well, did you get to this part?
Yeah.
Okay, basically right down to
Why is it
you
negative?
want to cancel off the loss, so you're dividing by this. If you physically write that step, you're going to make that mistake. You were trying to do that. All right, here we come. We got to spray, guys.